In this video, we're gonna take more exercises on the fundamental theorems of limits. Let me start by this one. Limit as x tends to 0 of x plus 4 all squared minus 16 over 2x. So by direct substitution for this function, we get 0 over 0. So we have to factorize this the numerator and try to simplify as possible as we can. So look at the numerator. We have up x plus 4 squared minus 16. This is a perfect square binomial, and the 16 is also a perfect square. So let's factorize it as the difference of two squares. How do we do the difference of two squares? If we have a squared minus b squared, so how do we factorize this? We have two terms and we have a subtraction sign, and both of them has a square power or even power. How do we take the difference of the two squares? We have two brackets. We have a negative sign in one of them and a positive sign in the other. Take the square root of the first to be a, square root of a squared to be a, and take the square root of the second, square root of b squared to be b. So this is how we do the difference of two squares. So we changed into the product of the difference and sum of the square root of each term. Now we will do the same thing. We will work with this binomial as one block, as one term. So let's see how do we factorize it. Limit as x tends to 0 of, we have two brackets, square root cancel the square power, so we have x plus 4, so we have x plus 4, keep it within brackets, and we have a negative sign here and a positive sign here, and then square root of 16 to be 4, and finally down we have 2x. Now limit as x tends to 0 of x plus 4, safely remove the brackets, plus 4 and minus 4, they cancel each other, so we have x, and here we have x plus 4 to be x plus 8, and down we have 2x. Now we can simplify by cancelling the x up and down, and we have finally limit as x tends to 0 of x plus 8 over 2. Now by direct substitution with x equal to 0, we get, or f of 0 is equal to 0 plus 8 over 2 to be 4. Now we're gonna do this one. Limit of x plus 2 all cubed plus 1 over 2x squared plus 6x as x tends to negative 3. In the numerator, we can consider this binomial as one block, as one term, and it's raised to the power of 3. Once you have the power of 3, think of a cube. We have two terms, so think of two cubes. We have addition, so this is the sum of two cubes. How do we factorize the sum of two cubes? Let's remember, if we have a cubed plus b cubed, so we factorize it into two brackets. In the first one we have, if it's plus, we keep it plus, take the cubic root of the first to be a, then cubic root of the second to be b, forget the original binomial and then work with this one. Take the square of the first to be a squared, the square of the last, and it will be positive, so b squared. For the middle term, change the sign, it's positive, so changed into negative, and take the product of the first times the second, so a times b, but don't multiply by 2. Now back to our exercise. We will do the same thing. So we have the sum, for the numerator we have the sum of two cubes because one is a perfect cube. So limit as x tends to negative 3 of, we have two brackets, a small one and a bigger one. We need more space. So for the first term, take cubic root of the first to be cubic root of x plus 2 all to the power 3. The cubic root cancel the power 3. So we have x plus 2. Keep the bracket and keep the sign as it is, plus take the cubic root of 1, which is 1. This is the smaller bracket. For the bigger one, forget the original expression and take this one now. We square the first term. This is considered to be the first term, x plus 2. So we square the x plus 2, raise it to the power 2, and for the last term we square this one and it should be positive. 1 squared to be 1. For the middle term, we change this sign into the opposite sign, so negative. And we take the first term times the second term. So 1 times x plus 2 to be x plus 2. This is the numerator. Keep the brackets. For the denominator, we have 2x squared plus 6x. It's only 2 terms, so and it's addition and no perfect squares. So the only way is to think of a common factor. The first term has 2x squared and the second term has 6x. So let's take 2 as a common factor. And for the variables, here we have x squared and here we have x to the power of 1. So take the least power of x, which is x to the power of 1. Now divide each term by 2x, by the common factor. 2x squared divided by 2x to be x. We subtract the power, 2 minus 1 to be 1. And plus 6x divided by 2x to be 3. And x divided by x to be 1, of course. Now simplify. This is equal to, limit is x tends to negative 3 of x plus 2 plus 1. X plus 2 plus 1 to be x plus 3. And for the second bracket, let's we have a perfect square binomial. Let's expand the binomial. Square of the first to be x squared, and square of the second 2 squared to be 4 plus 4. Take the first, for the middle term, keep the sign, it's plus. Take the first times the second times 2. So 2 times x to be 2x times 2 to be 4x. Now this is the first bracket. We can safely remove it because we don't have a negative sign outside. Now we change the sign of each term within the second bracket because we have a negative sign outside. So it's negative x and minus 2 and finally plus 1. Down we still have 2x times x plus 3. Now simplify. Look at this. Up and down you have x plus 3, so we can cancel the x plus 3. So this is equal to, limit is x tends to negative 3 of, here we have x squared and 4x minus x to be 3x, so plus 3x, and 4 and 1 to be 5, minus 2 to be 3, so plus 3 over 2x. Is a direct substitution. So let's try to find f of negative 3. This is equal to negative 3 squared plus 3 times negative 3 plus 3 over 2 times negative 3. Negative 3 squared will be 9, positive 9 because the negative sign is cancelled because of the even power. Then 3 times negative 3 to be negative 9, then plus 3. Finally down we have 2 times negative 3 to be negative 6. 9 minus 9 cancel each other to be 0. So we have finally 3 over negative 6 or negative 1 over 2. So the limit of this function as x tends to negative 3 is negative 1 over 2. Let me start by this one. We have, this is number 6. we have the limit as x tends to 2 of x to the power 4 plus x squared minus 20 over x minus 2. We have x to the power 4 and x squared. How do we factorize this? We have, if it's a trinomial, this is a trinomial, so let's factorize it as a product of two binomials. Now we have x minus 2. If we have x to the power 4, so this means x squared and x squared. If it's 20, so this means 5 times 4. It may work. So 5 times 4. And 1 is negative and 1 is positive. The middle term is positive, so put the positive sign for the bigger factor, for the 5, and put the negative sign for the other one. As a check, here we have negative 4x squared, and here we have 5, positive 5x squared. The difference is 5x squared minus 4x squared to be x squared. This is a correct factorization. Still, we cannot simplify. So we need more simplification. So what can we do? Look at this. Here we have x squared minus 4. Still we have a difference of 2 squares. This is a perfect square and 4 is a perfect square. So still we have the difference of 2 squares. Still we can factorize this binomial and keep this and this. So limit as x tends to 2 of difference of 2 squares. So take square root of the first. So square root of x squared to be x minus square root of the second to square root of 4 to be 2. And here we have square root of the same thing but with plus. So x minus 2 times x plus 2. This one we keep it as it is. So x squared plus 5, and down we have x minus 2. Now we can simplify this with this. Of course, the first step is to do direct substitution. If you do direct substitution from the beginning, you get an unspecified quantity. So we have to do simplification. Now we can do a direct substitution and find f of 2 to get the limit of the function. This is equal to 2 plus 2 to be 4 times 2 squared to be 4 and 5 to be 9. So times 9, which is we have 1 down. So this is equal to 36. Limit as x tends to 3 of 5 over x plus x squared minus 3x over x minus 3. We do direct substitution for the first part. We get a real number because it's 5 over 3. But for the second part, we get an unspecified quantity. So we have to simplify the second part. Let's start. So this is equal to limit as x tends to 3 of. Keep the first part as it is. And for the second part, try to simplify it. X squared minus 3x. The first term is a perfect square, but the second term is not. It's only 2 terms, but not difference of 2 squares. So think of a common factor. Here we have x squared, and here we have x means to the power 1. Take the least power of x as a common factor. So we have x outside. Divide each term by x. So x squared divided by x to be minus 3x over x to be 3. And down we have x minus 3. Finally, we can simplify the x minus 3. Cancel them together. And finally, I have up x. So this is equal to limit as x tends to 3 of 5 over x plus x. By direct substitution, you get f of 3 is equal to 5 over 3 plus 3 to be 14 over 3.